Hello, everyone. How are you all doing this fine evening? I understand after 2 full days of tech talks, your brain is probably fried. So you have some good news. My talk is going to be like really light, and I'll give you something to think about the next time you sit down to code. My name is Jyothsna Patnam. I am the co-founder of TypeLead, a company, the company behind the Eta programming language, which also offers commercial support for production users. My interest lies between the space where programming languages meets user experience. When I speak about programming languages, it's not just about the code. It's also about the tooling and the community. When you buy into a programming language, you buy into the entire package. So I've assembled these 3 major categories into this little diagram you see here, and now I'm going to expand a little more so that we're all on the same page. By core language, I mean, is the language a statically typed or a dynamically typed language? Is the fundamental concept a function or an object? Does it run on a virtual machine or compile down to native code? Does it have semicolons or indentation? By tooling, I mean, does it have a package manager? Or what IDE support does it have? So are the bugs easy to trace? Are the error messages easy to understand? By community, I mean, how accessible is the documentation? How easy is it to find libraries so that you can solve a problem at hand? Are there updates available on Reddit and Twitter? Does it have active chat rooms? Now that we've spoken about the value a programming language offers, we have to remember one thing, that human beings are involved in all this, and we call them developers. And the layer between the developers and the programming language is called user experience. Now, I'm going to speak about Eta in context with whatever we have just discussed. How many of you have programmed in Haskell before? OK. That's quite a lot. That's almost all of us. OK. Eta is a fork of Glasgow Haskell compiler that runs on the Java virtual machines. It compiles majority of the packages without any changes whatsoever, and some packages with some changes, which I'll discuss a little later in this talk. And our main focus for Eta is to make it as effective as possible for industrial use. Before we move any further, I want all of you to picture this diagram so that we have a perfect mental model when we discuss about the Eta programming language. Coming to Eta's core language. Eta is a pure, lazy, functional, Eta is a pure, lazy, statically typed functional programming language that interfaces with Java through a foreign function interface. Oh, wow, that's like a lot of jargon. So let's break it into small points so that we have a clear understanding of what this means. A pure function is a function that always returns the same output given an input. So this makes a pure functions deterministic, probabilistic, deterministic, and easy to test. Now let's see a small example. Say we have to calculate the product price after a discount of 20%. For every product price, you get the same discounted product price. So this amazing this amazing property of purity helps you refactor fearlessly. This makes your code really modular, and you really, and every part of your code is independent of the other. What is laziness? Laziness is an evaluation strategy which evaluates whatever is required at a particular time only. So it's not like the strict languages where you evaluate an expression completely at once. Moreover, in a lazy language, once an expression is evaluated, you don't have to evaluate it again. This is a simple expression where a list of elements are transformed by multiplying by 2, and then we take the sum of the elements. In a strict language, these are the reduction steps in a strict language. First, you multiply the list of the elements by 2, and then take the sum of the resulting list. Now let's see how it's done in a lazy language. In a lazy language, every pattern match forces an evaluation. For example, on this list, when we pattern match on it, we get access to the first element and the rest of the list. Here you can find the definitions of sum and the map functions. And the reduction steps look like this. So this is just for illustration purposes. This is not how exactly the Eta or Haskell compiler does it. There are a lot more complicated optimizations that go on, which I really don't want to discuss now. Now that we understand the now that we understand what laziness means, let's see a practical example where laziness can be useful. This is a simple example where the function checks if a list is empty or not, and prints the head of the list. Head of the list means the first element of the list in case it's not empty. Now let's do a slight refactor. We as human beings, we are so used to refactoring our code over and over. So let's do a slight refactor and introduce a binding called first, which takes the head of the list. Now, in a strict language, in the second program after the refactoring, the program will crash. Why? Because the first expression, that's the binding, will get evaluated, but in a lazy language, this doesn't happen. In a lazy language, as I told you before, the expression is evaluated only when it is used. So in a lazy language, you really don't have to worry about the order in which you write the code, because the data flow in your program takes care of itself. Types are everywhere in Eta. They are a way of labeling the data in your program so that you can precisely describe to your functions what they're doing. Here is a simple demonstration from the Eta REPL session, which demonstrates that pretty much everything in Eta is a type. The first one is a character A, which has a type, again, character. And yes, code mesh is awesome. It's a string which has a type list of characters. And the third one, 8.0, you have to keep in mind, it's a polymorphic literal, which can either take the type float or double, depending on the situation. The next interesting observation with this slide is that functions like plus and print also have a type in Eta. What does this mean to us? So when you give types to every expression in your language, that means you can give precisely what your functions can do, and the compiler will understand you much better. The more descriptive the types are, the compiler understands you. You can prevent several classes of bugs at compile time. So at the end of the day, types are very helpful to shift your runtime errors to compile time errors. And that is incredibly useful because we as programmers who work in industry, we're always iterating on our applications very fast. And this is a very important feature. Now let's discuss about how Eta interacts with Java. The interesting challenge we had to solve was to keep the basic concept of the language, that's the purity and laziness, when interacting with an object-oriented language. Here is a simple, I'll show you how this works with a simple example. This is a simple Java code where you have a simple class counter, which also has a private integer field called counter, and you can create an instance of counter, or you can create an instance of counter with an initial value of counter itself. You can also increment it. You can update it using the increment and set instance methods, and you can also use the get instance method to get the current value at any time. Now, when we write Eta code, the first and foremost thing we do is import the Java module. By importing the Java module, we are Java module, we are getting all the required types and functions that are needed for the interrupt system. The next step, we define something called the Java wrapper type. In this step, we are going to treat treat a Java class as an Eta type. In the last step, we're going to write something called FFI imports. This is the part where the impure Java functions are being converted into impure Java methods, sorry about that. Impure Java methods are converted into pure Eta functions, pure Eta types, okay. So now I'm going to show you a simple example by using all the types we just defined. This is a simple example where the Java function converts the Java expression into an IO type so that we can use this program in the main function. Then we initialize a new counter with a value 10. And also, after initializing a new counter, we run the Java action against it. So this has some state changes, or you can even read the program and print the final result over here. Writing so many imports is a tedious job, and we really, as programmers, don't want to do this. So one of our community members proposed the direct Java interrupt system, in which the compiler takes care of writing all the imports for you so that we can just concentrate on the core logic of the application. This is being worked on right now. It's in a pretty good shape. We'll probably release this feature as soon as possible. So in this part, I want to treat Eta as a better Java with additional benefits like types and also purity. Now let's move on to tooling. I'll briefly talk about Eta's tooling, the error messages, installation methods, IDE support, at least that's the build tool of Eta, the debugging scenario, and also how do you convert Java code to Eta code. The error messages, we've been working on making the error messages better in Eta, and this is the present function type mismatch error in Eta. We follow a basic structure which has 4 components. The first component is the smallest region where the error might have occurred. And the second component is why the error occurred in the first place. The third component is a probable fix to to correct the error. Say the probable fix did not work for our users, they can always go to this link where all the potential solutions will be up. In this example, checker is a simple function that takes 3 arguments, where you can just see the type signature here. And the interesting thing to note here is int is the missing argument, and it's highlighted. We have various ways to install Eta. As developers, we have so many preferences and environments, so we try to integrate Eta into as many tools as possible. But the most supported installation methods are Gradle and Atlas. We try to push Gradle as much as possible because it's very useful for polyglot JVM projects. And again, Gradle uses Atlas underneath, so Atlas is again, the second most supported as well. We also have other installation methods like Docker, Nix for our pure functional build tool, fans, and source installation, and also SBT. SBT is not in a working stage right now, but we'll get around to it eventually. The IDE support. This is a screenshot from the IntelliJ Eta support, which was worked on by Carrie Robbins. It's a simple import auto-completion feature. The basic plugin is in a working stage, but the advanced features like typed holds and code auto-completion will take some time. And we're also working on the LSP server for Eta. This gives us many ways. This opens up many ways for us because we can start working on the VS Code support. This is also going planned for the coming months. Atlas. Atlas is pretty much the backbone of Eta. Atlas is the build tool, which is a fork of Cabal, which is based out of Cabal. The few interesting features I want to talk today about Atlas are the version control system and the hash-based dependency management. So you can specify which version of Eta you can use to be used in your project. You can also, by simply using this command called atlas select, followed by the version number of Eta. You can also configure Atlas to use different versions of Eta for different projects on the same system. So in the JVM world, binary compatibility is always a big problem. So with Eta, we've introduced something called a hash-based dependency management system, where Atlas gives you a unique hash when every package is built. This actually allows you to use multiple versions of the packages, multiple versions of the packages on the same system without any issues. When your program throws an exception, this is how the stack trace looks like. I understand that it's a bit like unreadable, but we've tried our level best to make the names as simple as possible. So the best part of this stack trace is it actually points to the source file and also the line number where the problem occurred. So I've been trying to find similarities between Java and Eta code, and I've collected all my thoughts in this GitHub issue. So GitHub, yeah. For beginners, when they start programming in pure functional programming, it's always a hell because they are very unfamiliar with the difference in But yeah, as I was telling you, beginners always find it tough when they start pure functional programming. But a beginner familiar with Java code can easily convert to Eta code using a few simple rules. Here is a simple example of a Java web server that's been converted to Eta. In the first line, you can see that the Java variable declaration is converted to a binding operation in Eta. In the second line, the Java in the second line, you can see that the Java instance method call can be done using the fancy operator in Eta, fancy dot operator. I've converted many examples like this, and this is a little non-trivial example. This is a simple word count Flink example that's been converted from Java to Eta, which you can look into it in detail later. So now that we've seen that it's just a few simple rules and this process can be automated, we have plans to automate this conversion using a tool similar to Kotlin's converter. Let's move on to community. I'm going to speak a little bit about our documentation, tutorials, chat rooms, and social media here. This is a screenshot of Eta Documentation Center, where we have user guides for the language and all the tools that are integrated with Eta. We also have beginner-friendly tutorials, a tutorial, for example, loops to recursion or something like that. And we also have cheat sheets. Say a beginner wants to get started with pure function programming, we have a tour of Eta, which is like a book which has chapters from the basics of the language to the advanced topics like monads and functors, which I'm not going to speak now. OK. We're very active on GitHub if you want to keep up with the pulse of the programming language itself. We're also on Slack. And we actively share the updates on Twitter. The roadmap for the coming months involves direct Java interrupt, IDE support, and documentation. Documentation also involves the API documentation called Atlas. This is a repository of all the packages that work with Eta. This will be out in the coming months. I want to talk about a little bit about emotional experience. We work every single day with several tools, and we interpret hundreds and thousands of error messages every single day. Isn't it frustrating? So what I'm trying to do is bring some emotional experience into our tooling itself. So it's nice when the computer just pats your back and says, yes, you're doing some great work, or don't worry, you still can do great work. Say you have an error, you still definitely can do great work. So this is the first one is when you have an error, you have an emotional message like this. And the second one is you get a pat. I want to share about a cool thing you can do with Eta. You can actually write code in Haskell and build 3 types of apps using Eta. Say you want to develop a game, and you can write the game logic in Haskell and compile it to native code. Or with Eta, you can build a desktop application using the JavaFX graphics API. And you can also build an Android app using the Android graphics API. So what I mean to say is just think of the green layer as the game logic and the second layer as a graphics API. The game logic for all the 3 programs is the same, but the graphic API for Haskell, you can use Glass. For the JVM app, you can use JavaFX, and for Android, you can use Android Android graphics API. So, yeah, I think, yeah, that's it. Thank you so much. Yeah.
Oh, that was, cheers, Lars. So you said that Eta is basically the Glasgow Haskell compiler for the JVM, but I mean, clearly you have re-engineered the error messages. Just how much of the code of GHC is still there, or is it like a complete redevelopment?
That took almost a week. We had to refactor almost 2K of lines. So it took a lot of refactor. We had to make a common data constructor for this, and yeah.
Any more questions?
Yeah.
Oh, yeah.
Thank you for your talk. At what point did you fork GHC? You know, particularly things like language extensions. How many of those are still available?
In the initial stages, Eta was a fork of 7.10.3 GHC compiler, but at the current stage, we have you heard of Backpack? So we ported that recently to Eta, so it's pretty much 7.3 with some, GHC 8 extensions as well. So language extensions like applicative do, and all have been ported back to Eta. Yeah.
Any more questions? We've still got quite a bit of time.
Just curious, how do you handle inheritance in Java? I mean, we imported a data type, but in Java there is this inheritance relation. How is it modeled in Haskell?
Can you repeat the question again?
So we saw the counter. Let's say I extend this to also allow, I don't know, decrementing counters. And this is a separate type, but it's this new enhanced counter is also a counter. So would they be two totally unrelated types in Eta, or I don't know, there would be some conversion?
So this idea I talked to you about, the conversion from Java to Eta code, is still in the ideation stage. There's a lot more work to be done. Probably we can take this offline, and I can tell you more thoughts we have for this tool. Yeah.
Anyone else? No. Cool. Well, thank you very much. That's excellent.